Good morning everyone and good morning sir. This is my presentation and this is my topic on internal combustion engines. Objectives. Number 1. Be able to list and describe the events that occur in the internal combustion engine. Be able to describe how spark ignition Otto cycle engine differs in operation from a compression ignition diesel cycle engine. Number 3. Able to diagram and describe the events that the occur in sequence during each stroke of a 4-stroke cycle engine. Be able to diagram and describe the events that occur in a 2-stroke cycle engine. Given the bore stroke, number of cylinders, and clearance volume, be able to calculate the piston displacement, engine displacement, and compression ratio in both customary and SI units. Introduction. There are 6 primary sources of power in agriculture: human labor, domestic animals, wind, flowing water, electricity, and heat engine. Kini siya kay naatay unom ka source of power agriculture. Kining mga human labor, domestic animals, wind, flowing water, and electricity and heat engines. And the primary source of power for modern agriculture are the internal combustion engine and electrical motor. Kini siya natay kanang kanjud siya kanang primary source jud siya kanang sa modern agriculture kaning internal combustion engine and electric motor. Someday the primary source of power may change to fuel cells, solar energy, or atomic energy. But in immediate future, the primary source of power for agriculture will continue to be internal combustion, heat engines, and electric motors. Internal combustion engines used to agriculture application range from those used for 1 horsepower garden tools to the hundreds of horsepower required for very large structure. Because engines are very common knowledge of how and why they work is essential to successful agriculture manager. Kini siya kay kuan ni internal combustion engine kay gamit kini siya sa mga agriculturists. Then dali ra siya mabaw-an kay kanang tungod sa kadaghan sa karon nga mga teknolohiya kanang mga bag-o gani. Tapos kan dali ra siya kanang mabaw-an, tas dali sa process, tas ang mga agriculture manager kay kanang magamit nila in kanang kuan in future kanang mga magapang nagkuan eskwela. Then theory of operation. The function of all internal combustion engines is to convert fuel chemical energy to power. Kini siya kay kining function siya kanang i-convert ta siya kanang fuel to chemical energy to power. Nihimo siyang power, convert man ang fuel mo create power. This is accomplished by burning a fuel in a closed chamber and using the increase in temperature within the closed chamber to cause rise in pressure. Kini siya kay ginasunog ang kaning fuel sa kanang sarado na chamber, din patasan ang kaning temperature sa kanang gisaradan sa chamber to cause in rise in pressure kanang mutaas ang pressure. The pressure produce a force on the head of the piston causing it move. Kini siya kay mo naka-create siya force kay kaning causing to move na siya kaning tong gisunog gani. Tapos siya mahimo siyang kanang mo ka-produce siya kanang force, then causing of moving kanang move maka-move siya ba. The linear movements of the piston is converted to rotary motion at the crankshaft. Fig 1.1 rotary motion is more useful than linear movements. All internal combustion engines have 8 requirements of operation. Number 1. Air oxygen is drawn into the engine cylinder. Number 2. Quantify a fuel is introduced into the engine. And 3. The air and the fuel are mixed. 4. The fuel-air mixture is compressed. 5. The fuel-air mixture is ignited by the spark plug in gasoline engines or by the heat of compression in diesel engines. Number 6. The burning of fuel-air mixture causes a rapid pressure increase in the cylinder which acts against the piston, producing a force on the piston. And number 7. The use of connecting rod and crankshaft converts the linear movement of the piston to rotary motion. The force on the piston is converted to torque on the crankshaft. The products of combustion are expelled from the engine. Mo ni siya kanang katong sa parts of internal combustion gasoline engine kining nasa carburetor, intake valve, spark plug, muffler, exhaust valve, piston rings, crankcase, crankshaft, counterbalance weight, connecting rod cap, crank pin, connecting rod, piston, air filter, muna na siya. Then pakita to yung mga kanang yung mga function kini siya. Air filter are used in application where air quality is important. Notably in building, ventilation system, and engines. Carburetor for mixing air with a fine spray of liquid fuel. Intake valve control the passage of fluid or air into the pipe, channel, or duct. Spark plug for delivering electric current from an ignition system to the combustion chamber of a spark ignition engine to ignite. Muffler for reducing the noise emitted by the exhaust and an internal combustion engine, especially a noise deadening device from parts of exhaust system of an automobile. Exhaust valve. A pop-up valve is a valve typically used to control the timing and quantity of gas or vapor flow into an engine. Piston ring. Sealing the combustion chamber so that there is a minimal loss of gases to crankcase. Crankcase is the housing for the crankshaft in a reciprocating internal combustion engine. Crankshaft counterbalance weight are designed to offset or balance the inertia effect of the relatively heavy piston and connecting rod moving in both rotational and reciprocating up and down fashion. Connecting rod cap is the removable section of a two-piece connecting rod that provides a bearing surface for the crank pen journal. Crank pen is a mechanical device in an engine which connects the crankshaft to the connecting rod for each cylinder. It has a cylindrical surface to allow the crank pen to rotate relative to the big end of the connecting rod. Connecting rod is the part of a piston engine which connects the piston to the crankshaft. Piston. It is a component of reciprocating engines, reciprocating pumps, gas processors, hydraulic cylinders, and pneumatic cylinders, among other similar mechanisms. Four-stroke cycle. Kini siya kay four-stroke cycle, four-stroke also four cycle. Engine is an internal combustion mo siyang IC. Engine in which the piston completes 4 separate strokes while turning the crankshaft. A stroke refers to the full travel of the piston along the cylinder. In either direction, the 4 separate strokes are termed intake, also known as an induction or suction. The stroke of the piston begins at top dead center kining TCD kay kunya TCD the and ends at bottom dead center is BDC. In this stroke, the intake valve must be in the opponent position while the piston pulls an air-fuel mixture into the cylinder by producing vacuum pressure into the cylinder. Through its downward motion, the piston is moving down as air being sucked in by the downward motion against the piston. In compression, this stroke begins at BDC or just at the end of the suction stroke and ends at TDC. Is in this stroke the piston compress the air fuel mixture in preparation for ignition during the power stroke. Below, both the intake and exhaust valve are closed during this stage. Combustion, also known as power of ignition, this is the start of second revolution of the 4-stroke cycle. At this point, crankshaft has completed a full 360-degree revolution, while the piston is at TDC, the end of the compression stroke. The compressed air fuel mixture is ignited by a spark plug in a gasoline engine or by heat generated by high compression diesel engine, forcefully returning the piston to BDC. The stroke produces mechanical work from the engine to turn the crankshaft. Exhaust, also known as outlet, during the exhaust stroke, the piston once again returns from BDC to TDC while exhaust valve is open. This action expels the spent air fuel mixture through the exhaust valve. Then the fourth stroke of the 4-stroke cycle mo ni siya kaning intake, compression, power, exhaust mo ni kaniyang natuyok siya oh. Intake open, exhaust close. Mga deadline mga kan kini two-stroke cycle. A two-stroke or two-cycle engine is a type of internal combustion engine that completes a power cycle with two-stroke up and down movements, pataas ug baba, then of the piston during only one crankshaft revolution. This is a contrast to a 4-stroke engine which requires 4 strokes of the piston to complete a power cycle during 2 crankshaft revolution. In a 2-stroke engine, in the end of the combustion stroke and the beginning of the compression stroke happen simultaneously with the intake and exhaust or scavenging function occurring the same time. Two-stroke engine often have a high power to weight ratio, power being able in a narrow range of rotational speed called the power band. Compared to 4-stroke engine, two-stroke engine have a greatly reduced number of moving parts. Muni siya kaning parts of a two-stroke cycle engine kining exhaust ports, combustion chamber, red valve, air filter mo din siya, carburetor, crankcase, intake ports. Type of engine. Basically, the engines are of two types, and there are external combustion engines and internal combustion. Nasa duha kanin silang kuan, external og internal. And internal combustion engines kay internal combustion engines, the combustion of fuel take place outside in engine. Kining steam engine mo na example niya. Tas internal combustion engine kay the combustion of fuel takes place inside the engine. Two-stroke and forced petrol and diesel are the example of internal combustion engine. Kaning siyang mga example ning kining for petrol and diesel engine kay maning siyang example niya. Kining mo na yung type of design kining vehicle rotary engine, reciprocating petrol engine mo na sila mga naong sa kan. Kining reciprocating engine kay and there is a piston and cylinder. The piston does reciprocating to and fro motion within the cylinder due to the reciprocating motion of piston. It is called reciprocating engine. Two-stroke and four-stroke engines are the common example of reciprocating engine. Rotary engine. Rotary engine in the rotor does rotary motion to produce power. There is no reciprocating motion. A rotor is represented in the chamber which does rotary motion inside a chamber. One Winkel rotary engine turbine engines are the rotary types of engine. On the basis of type of fuel use, the engine is classified as petrol engine, diesel engine, and gas engine. Kining petrol engine kay with use petrol, it's working called petrol engine. Tas ano siya, diesel, tapos diesel engine, marami siya, gas engine, fuel gas, kawag sa gas engine. Muna na siya. Then one of busy cycle operation, the engine types are auto cycle engine. Ganing auto cycle kay types of engine work on auto cycle. Mga auto gani. Diesel cycle engine, the engine working on diesel cycle is called diesel cycle engine. Dual cycle engine or semi diesel cycle engine. The engine that works on both diesel as well as auto cycle is called dual cycle engine or semi-cycle. Ay kanang dapat kaning duha siya mo function sa duha. Kining sa auto cycle engine og semi-cycle engine duha siya. Kining displacement. Displacement is a cylindrical volume that a piston displaces as it moves through one stroke. It is equal to the area of the piston multiplied by the length of the stroke. Stroke equal to area. Displacement is one of the factors that determine the amount of horsepower an engine will produce. The greater the displacement and greater the volume of air and fuel that is burned during combustion, which means more power. Expressed mathematically, piston displacement is piston displacement equal muna siya basta muna ni siya kuan ni sa ubos where PD piston displacement is cubic inches in 3 ay 3 siya. Tas B bore of cylinder diameter in inches in. S stroke of piston in inches. The bore and stroke of an engine has been traditionally expressed as V times S with the dimension in inches. Thus, if B times S equal to 3.50 times 4 point, and the piston displacement is PD equal R times masa di ko balo magkanani para sa mao na ni siya kaning nasa ubos equal ni mo na ni gawas o kaning kining 38.5 inches kay convert naman ning kaning 38.484 kay himo naman kay 8 mo ning sunod ang 4 kay 8 mong sunod himo na siyang 5 mo ni siyang answer 38.5 in 3 nasa babaw. Then larger engine are constructed with more than one cylinder. For multi-cylinder engines, the term engine displacement ED is used. Engine displacement. It is the product of cylinder displacement times the number of cylinder express equation from ED to PD xn, where ED engine displacement in 3 version PD piston replacement 3 in n number of cylinder in cylinder din. If the engine in the previous sample a 4-cylinder engine, then the engine displacement is ED P equal to PD xn equal 38.5 times 4 equal 154 in 3. It is a common practice to combine these two equations for a single cylinder engine. The volume for one equal n equal 1. ED mo ning example niya sa kaning formula. Then sunod natin sa compression ratio. The compression ratio is the ratio of the total volume in the cylinder to the clearance volume. The clearance volume is the volume of the combustion chamber when the piston is at TDC. Fig. 5.7. The total volume is clearance volume plus the displacement. The compression ratio is an engine characteristic related to engine efficiency, that is ability of the engine to converted energy in the fuel to useful mechanical energy. The greater the compression ratio, the greater the potential efficiency of the engine. The maximum compression ratio that can be obtained is function of the type of fuel and the physical strength of the engine components. A compression ratio of 7 to 8 1 is common for gasoline engine and a ratio of 5 to 22 is common for diesel engine. Express mathematical compression ratio is mo na yung kaning yung CR PD plus CD tawag na CB man na siya. Basta kamanay ko na. Okay. Mo ni ang figure sa kanang cylinder clearance volume mo na yung naong kaning na TDC clearance volume na mo na siya. Where CR compression ratio, PD piston displacement in 3 verse 3 and CB clearance volume in 3. Problem, that is the compression ratio for a single cylinder engine with a B times S of 32.25 times 3.75 in the clearance volume of 6.20 in 3. Solution. The first step is calculate the displacement. Ay kasi calculate na to daan ning siya kay iya tong ikuan kini siya o ning 3 point mo na niyo 3.14 times mo ni 3.25 inch so 4 na siya daan mo ni ang formula. This morning answer niya 31.09 tapos i-convert na siya kuan 31.1 in 3. Then the compression ratio is 3 kaning mo na yung kuan T1 60.0 as ratio of 06.01. Notice that the answer has no units. To have a ratio, the units in the numerator and denominator must be the same. Thus, the unit cancel each other. Comparison ratio of 6.0 would be expressed as 6.0 verse 1. Theoretical power. The theoretical or indicated engine horsepower can be determined using the mean effective cylinder pressure MEP. The indicated or theoretical power is the power produced in the engine by combustion of fuel. It does not account for power loss to friction and other losses. The equation or calculating indicated engine power in units of horsepower for 4-cycle engine is ano man ang example ang talong nyo kay the equation is changed for 2-cycle engine change siya ano siya where P means effective pressure PSI, S equals stroke, E cylinder area, into N engine speed RPM, and number of cylinder. Note, the dimension of stroke in this equation is feet to cancel out the units of feet in the 33,333 constant. Problem. Determine the indicated horsepower for a 4-cycle cylinder engine that has a mean effective pressure of 152 psi and the bore is 2.75 in the stroke is 2.65 and the engine speed is 3000 rpm. Solution. The engine power for 4-cycle engine can be calculated using the following equation. So guys, mo ni siya ang kuan kining formula niya. Bro, lisod-lisod din siya okay, wala ko kay ko nasabtan ani pero mo jud ni siya ang answer o kani 9.0623 or 9.06 EHP mo ni siya ang answer. Divide mo ni siya mo ni siya nakuha. Metric problems. The units of engine power in a SI system is the kilowatt. Piston bore and stroke are measured in millimeters. Displacement is reported in liters. 1 liters equal to 1000 cm or 1,000 1 million mm. 3 measure is measured in kilopascals. The equation of engine power in kW is mo na formula niya guys. Kining EKW equals px times kung divide sa aning 60 6,000 x2 then xn. The pressure PE and S stroke M, the E piston area, and speed RPM. Mo ni siya. Kining problem determine our indicated engine power for an engine in units of kilowatts. What has a mean effective pressure of 1000 kPa and the engine is a 4-stroke cycle engine as 3 cylinders. The bore B is 109 mm. The stroke is 115 mm and the speed 3000 rpm. First converted the units to basis SI units. 1050 kPa 1000 kip times ano ni siya muna guys kay ano yung Formula 1 pag convert. Next, calculate the area of the piston. Ano siya nahimo siyang 0.00933 m2 muna siya ang answer kay gi-convert naman siya oh. Then finally determine the power kilowatts. Kini siya kWo. Muna siya yung mga formula kay taas ini siya oh. So yung answer kay 28.163 then or 28.2 na siya kay di ko naman siya convert. Problem, calculate the compression ratio for the engine in the previous problem if the clearance volume is 0.63 yung 1 L. Solution, since we are calculating the ratio, any consistent set of unit can be used. Engine displacement is usually expressed in liters, therefore is this example the displacement is converted to liters because the clearance volume is units of liters. Start by calculating the piston displacement. Muna siya guys. So, ang answer na siya kay tayo sa formula tapos muna yung ang answer kay 1.07 L. Muna siya, i-convert naman siya oh. Then next, calculate the compression ratio. CR PD plus kuan si 1 ni answer niya 17 pero ni convert na siya to 18 to 1 kay naman ano siya oh. Muna siya answer 18 to 1. So guys, kung na nahuman akong presentation, so thank you and God bless.